Okay, so starting our trig, we're going to start out with some basic stuff. So here's the first thing. A reference angle is our angle that is positive, an angle that is acute or right, not obtuse. Okay, do we know what those words mean, acute and obtuse? I always think cute things like babies and kittens are small, so this is less than 90. Okay, and obtuse, so we don't want to be bigger than 90 when we talk about that, okay? Don't be bigger than 90. And the last important thing is it's connected to the x-axis. So which axis can I attach myself to? I can attach myself kind of in those ways. Okay, do you see how my attachments are connected to the x-axis? I'm swinging off the x-axis somehow. Okay? That's important to remember. I never want to see you using the y-axis values. Okay, now, actually I'm just going to skip down and then we'll go back to this second question. So here, this is the start, okay? This is where we start from on the right side. So this is quadrant number 1. And if you're in quadrant 1, you're going to be between 0 degrees and 90 degrees. Okay, we move around the circle. So this is number 2. If you are in number 2, you are between 90 and 180. And then quadrant 3, if you're in quadrant 3, your number is between 180 and 270. And if you're in quadrant 4, you're going to somehow be between 270 and 360. Okay, so this spot can be 0 or 360, right? It has kind of two numbers we have to think about there. Okay, here we go. Draw. So when you draw, here's the 2 points awarded. Did you draw its movement, like swivel? And did you draw where it's going to stick out and land? Okay, so here we go. 108. We're going to start here, and we're going to pivot. Tell me when to kind of stop. Stop. Okay, so that's how much I've spun. And then it's like a clock, and we're just going to draw it's called a terminal arm. If you see that word, it's like the clock arm. Okay. Oh, negative. What do you think that's going to do for my spinning? I'm going to spin downward now. I'm going to spin the opposite direction. So I have to spin backwards for 125. Ooh, 400. This one's a little bit weird too. What do you think could happen here? 360 and then a more spin. Okay, so if you're into skateboarding or like something like that, right? You're thinking about your spinning, making your way around. So I'm going to do this. 400 subtract 360 is how much extra? 40. Okay, so you're going to spin. Here we go. Spin, 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 spin. Full circle. And 40 more. that make sense on my little spin around? Do you see it? I made an entire spin and then 40 more. Okay, if it helps, 45 is smack in the middle, right? 45, so I'm just a little bit under the halfway point. Okay, 226. How would I draw 226? So here we go. This is to go 90, 180. Okay, well that's 270, so I shouldn't go that far. So there I am, somewhere in that zone. Quadrant 3. Sometimes questions on the provincial just be like, which quadrant are you in? Okay, so that's drawing. Now, here's what a reference is. How much space am I between the x-axis and my landing arm? So here's what I'm wanting to know. For this one, where's the closest x-axis connector? This. I'm closer to this than that one, right? So I need this number is called my reference amount. How would I mathematically calculate that using two values that I could put together somehow? 180 subtract 108. So the entire semicircle, subtract that, leaves me with that chunk. Do we see why we're doing that? 72 degrees. Okay, what did we say about this number? Has to be positive, has to be not bigger than 90 degrees, right? Because if you're bigger than 90 degrees, it means you're actually closer to the other axis, right? Okay, number 2. So where's the reference amount? Where's my closest x-axis space? Right here. So there's an amount. So what am I thinking about with my calculation there? 180 subtract 125, okay? I'm not even considering that negative 125. I don't need that, because it's a distance of 180 subtract a distance of 125. $400 degrees. So what would the reference look like? It would look like that amount of space. From where I am to the x-axis, we actually already figured it out technically, right? We're 40 off of that. And the last one, what would it look like as a reference? It would be the space in this zone, so where I am to the x-axis that's closest. Okay, I have to do a little bit of a different math here. What would be a good idea to do? Okay, I don't want to use 270. Okay, why do I not want to use 270? Which axis is that representing? A y-axis. So that's a general rule. You're never going to use a 90 or a 270 when you're using your calculations, right? Okay, I'm not going to use 360 because I'm not closer to that side. 226 subtract 180. Okay, if I color code it, 226 subtract 180. Any more colors? Subtract 180 leaves me with, do you see that subtraction? 226 minus the 180 leaves me with that. Okay? 6, what is that? 12, 46? Okay. What would have happened to you if you used 360 in this? 360 minus 226 Is that a reference angle? It can't be. Why? It's more than 90. Can't be a reference now. Okay, so now that we talked also about our positioning, what do these letters mean? Okay, so all trig are positive in quadrant 1. All the trig. And when I say all trig, I'm going to refer to sine, cos, and tan. In quadrant 2, you're going to have an S, which means sine is positive. Okay, which means also what can I know about cos and tan? Cos and tan are negative then. Moving to quadrant 3, it's going to have a T in it, which is going to represent tan being positive. All right, so then I know sine and cos would be negative. And then in quadrant 4, that's a C. So what's the last combo here? Cos is positive. Okay, so there it is. Astica. Astica. I keep referring to that. That's where it's coming from. Okay. If you forget, I have this funky thing called all soup turns cold. So that helps you remember it. All soup turns cold. Or you can make up your own weird thing if you need to remember it. Okay, let's test something. Who wants to try, I don't know, let's try one of these quadrants. Should we go to the T? Okay, let's test the T. I need you to give me an angle that's in that quadrant. So your number you're picking has to do what? Be between 180 and 270. So I just need any random angle. 250, 230, whatever. Okay. Here we go. Run it into your calculator. What is the sine of 250? So you're going to go sine of 250, and it equals a negative value. Can you try doing the cos of 250? Oh, negative number. The tan of 250 came out positive. And there's y. So that's what we developed, okay? Okay, am I good to not test anymore? Do you believe me? That's how it's going to work whenever you pick an angle. Okay, these numbers that are coming out into your calculator are called trig values. This that we just popped out here is a trig value. Okay, so all this astica is referring to the trig values. The trig values are positive. Okay? Okay, here's a little cheat. Ready? Sine. Sine is positive in the up and negative in the down. So it splits up down. Cos, where is cos positive? A and C, so it's positive, negative. So how does cos split apart. Okay, you're going to later learn that sine's always connected to y, and cos is always connected to x, by the way, for another day. Tan, where's your tan positive stuff? A and T. So it splits apart diagonally. And later you're going to learn that tan is taking the x and the y and dividing them. So, okay, here we go. Oh, should have picked a different. Okay, here we go. Tan, sine, cos, and tan of 200. Well, first of all, where's 200? Which quadrant are you in? (200 degrees is here in number 3, which is connected to the T quadrant. So the tan of it will be positive, but the sine and cos of it will be negative. Okay, so this is what this question is going to ask. Where is sine? And do you guys know your inequalities? This says what compared to 0? More than? So if you're more than 0, this is positive. And what does this one say? That says less than 0. So if I'm less than 0, I'm looking for negative. Okay, so here's what I'm going to do. I'm going to draw 2 little quadrant maps like that. Okay, so where is sine positive? In the tops. Where is cos negative? On the left. So which quadrant is the and? Both things are happening. Top left, so it's quadrant number 2. It's in the S, but we'll call it quadrant 2. Okay, second one. Where is tan negative? So diagonal, which diagonals are we negative? Quadrant 2, 4. Where is sine negative? It would be negative in the bottoms. So which quadrant will we have both things happening? In quadrant 4. Okay, I'm not going to draw this third one because cos is positive and sine is positive. What's the only quadrant where we could have that happening in? Quadrant 1, yeah. In all positive. Okay, that's the only time more than one thing can be positive. So that's an automatic quadrant 1. No, because it's saying which quadrant. So our quadrants are called 1, 2, 3, 4. Yeah. The ASTC is a different kind of description of the quadrants. But. Okay, and then the last one you have to think about, what's the double situation? So tan positive is a 1, 3 diagonal. And this one says sine is negative, so it's bottoms. So where is the occur twice situation? Quadrant 3. Okay, I want to give you, I don't know, let's go one question here, or 2, let's see. I want you to flip to this one. It's a whole page flip, and it's on the bottom. It's a whole page flip, and then this is on the bottom. Are we good to find it? Okay, so this is the very basics of solving an equation for an angle. Okay, this decimal is called the trig value. That's a trig value. Okay, so here's what we're going to do. First of all, I'm going to say, hey, where is sine going to give me that positive trig value? Which quadrants? I have two quadrants I could be positive in with sine. 1 and 2. So I could connect myself here. I can connect myself there. Okay, these are that reference connectors, right? In quadrant 1 and quadrant 2. So I know I have to be in the top somewhere. Okay, so second thing, I'm trying to now get myself into an angle. Who knows from our unit with trig, how do you always get an angle? What's your button pushing stuff going to be? Inverse. So you're going to sine inverse and the trig value. (22.7 degrees). I'm going to follow our rounding rules where I've been saying from unit 1, everything 2 decimals, but angles we're just going to go 1. Is that good? Everybody's there? This number is called the referenced number. We talked about what a reference means. So I'm 22.7 connected to the x-axis of a space. So what is my answer? What is this angle going to be if I'm this much past 0? 22.7. This angle seems to be connected to this line, which is which number on this line? What's the angle on the line? 180. Are you connected in a way that you're less than 180 or more than 180? What do I look like? Do I look like I'm past 180 or before 180? So my calculation is going to say 180 minus that number. Okay, you ready for the aha moment? Do you remember the ambiguous triangle? This is why. Sine, remember? That was the ambiguous triangle. We had sine values twice to give us the same result, right? Okay, so look at that. Let's try it. Can you go sine of 157.3? Check it out. See, does it get you to that trig value also? Yep. So it works, right? Okay, one more and then we're done. Okay, so here's the cos angle is, and again, this is called a trig value. And it's negative. So if I think about my little quadrant-y stuff, cos can be negative. You know your numbers? Cos can be negative where? Okay, so I'm going to kind of draw myself a little map here. I could be here or here. And if I'm connecting myself to an x-axis, it would look like that connection. All right, now, here's a big deal. When you are now going to go into your calculator and cos inverse. You are not going to do the negative. Okay, here's why. We have already applied the negative in our location. Okay, so we don't need to apply the negative in the calculator. Okay, it'll get us all wonky because it'll either give us an obtuse or a negative angle. And we're trying to look for that positive reference angle. So cos inverse without the negative gets me to 50 degrees. Okay, I'm just going to show you what would have happened if I had done the negative. Okay, it would have given me 130 reference angle, which is not a reference angle now, right? It's too big. Okay, so this would be what? 50 degrees before 180, so I'm going to do 180 minus that. So the measure of this answer is 130. And then this one is going to be past 180, right? So I'm doing 180 plus, which is 230 degree answer. Okay, you can check your answers by replacing it. You can go cos of 230. Does it get you to that number? Okay, so this is when I said you're never using 90 or 270 ever when you're doing some kind of calculation. You're going to use 0, 180, or 360 are your only options. Okay, and don't put the negative in the math. Put the negative into the drawing.